In this video, I'm going to explain the concept of multiple LEDs. That means 5 LEDs blinking in increasing order from left to right. I will demonstrate this one. This is the very useful one related to Ardunio. Multiple LEDs. Five LEDs blinking in increasing order. From left to right. From left to right. That means here some lines are used here. The first LED is made to blink one time. The first LED is made to blink one time. The second LED is made to blink 2 times. The third LED is made to blink 3 times. The fourth LED is made to blink 4 times. The fifth LED is made to blink 5 times. This is the multiple LEDs. Consider 5 LEDs blinking in increasing order from left to right. First procedure. Choose 5 LEDs with the different colors from Tinkercad. Choose 5 LEDs with the different colors. From Tinkercad software. Second point is choose Ardunio board. Choose Ardunio board and breadboard. From Tinkercad. Third one is choose 5 220 ohms resistance. Choose 5 220 ohm resistances. Fourth one is all 5 LEDs cathode legs are connected to ground. Fifth one is all 5 LEDs with different colors. Anodes anode legs are connected to 5 digital pins, 5 pins of the Ardunio board. That means UNO. Once these connections are completed, next second step is code written, sketches. For 5 multiple LEDs blinking, increasing order from left to right. First one is preparation block. This one is wide setup. Configure the pins. First one, pin mode. Pin mode 13. Output. You have to choose 5 pins from Arduino board. 13, 12, 11, 10, 9. All these are pins are assigned as outputs. Configure these pins as outputs. Pin mode 13 output. Pin mode 12 output. Pin mode 11 output. Pin mode 10 output. Pin mode 9 output. These are the 5 pins. Here some bracket is there. Curly bracket, starting curly bracket and closing curly brackets are very important. Configure these 5 pins. These 5 pins are acts as output pins. Next step is execution blocks. Perform the actions. While loop. Here curly bracket is open. Some double slashes. Compiler ignores these statements after 2 slashes. The first LED is made to blink one time. Blink one time. That means here by using a digital write, set these pins either high or low. First pin is 13. Digital write. Digital write. Pin number is 13. Set high. One time blinking means high and low. HIGH high. Delay 100 milliseconds. Okay. Digital write. Thirteenth pin low. Delay 100 milliseconds. Okay, coming to next one is the second LED will blink 2 times. First LED blink 1 time means by using this one, these statements. Next, the second LED will blink 2 times. Here 2 times means here we use some for loop. For integer I is equal to 1, I less than 3, that I plus plus plus. curly bracket is open. Digital write. Digital write. That means the 13th pin completed, 12th pin. 12th pin high. Delay 100 millisecond. Digital write. Twelfth pin low. Delay 100 milliseconds. Without this using this for statement, write a digital write 12 high, delay 100 milliseconds. Digital write 12 low, delay 100 milliseconds. And again, digital write at 12 high, delay 100 milliseconds. Digital write at 12 low, and delay 100 milliseconds. 2 times. Same statements will write 2 times. Instead of the 2 times, here we use for statement. The loop is repeated 2 times. So initial I is equal to 1, I less than 3. Next increment the I value, I plus plus, that means 2. I is equal to 2 less than 3. Okay. Okay. I plus plus 3. Here I is equal to 3. 3 equal to 3. That condition is not satisfied. Therefore, under that loop, these statements are executed. Compiler execute these statements. Next step is the third LED. The third LED blinking, blink 3 times. Blink 3 times. Again, we use for loop for integer I is equal to 1, I less than 4, I plus plus, curly bracket open. Okay. Digital write. Digital write 11th pin. For 11th pin high, delay 100 milliseconds. Digital write low, delay 100 milliseconds, and the curly bracket is closed. The loop is 3 times repeated. These statements are executed. 3 times the LED is blinking. Third LED. Next, the fourth LED blinking 3 times. The fourth LED is blinking 3 times, blinking 4 times. Again, we use for loop for integer I is equal to 1, I less than 5, I plus plus, curly bracket open, digital write, the 10th pin high, delay 100 milliseconds, digital write 10 low, delay 100 milliseconds. Last one is the fifth LED is blinking 5 times. The fifth LED is blinking, blink 5 times. Again, we use here closed bracket. Here we use for integer I is equal to 1, I less than 6, I plus plus. Digital write. Digital write 9th pin, high, delay 100 millisecond. Digital write 9 low, delay 100 milliseconds. Finally, this bracket is closed, curly bracket, and one more bracket is used to close the entire program. Exit 1. This curly bracket for exit 1. This is the code or sketch for these 5 multiple LEDs blinking in increasing order from left to right. Now I will demonstrate this concept by using Tinkercad. Everybody must having a Tinkercad account, otherwise circuits are not created. Sign in by using credential login. This type is displayed. The type of sections are displayed here. My name is K. Murtiraju. These are the sections are displayed. I am pick up circuits column, circuits 1, create new circuit, create new circuit. Here some name is indicated here. That is multiple LEDs, multiple LEDs blinking in increasing order. Increasing order from left to right. Right. That means 5 LEDs. This is the space. Choose breadboard. Breadboard. From this one. Next, UNO board, Ardunio. This one is selected. And then 5 LEDs, different colors. Resistance are 5. 5 LEDs. So this one. You have to change this value 1 kilo instead of 1 kilo ohms. 220 ohms are used here. 220 ohms. Click on that one. Control C and Control V. Click on that one. Control C and Control V. Click on that one. Control C and Control V. Control C and Control V. C and Control V. 5. And similarly, this one. Control C and Control V. These are the 5 LEDs. First one is a red color. Second one is a blue. Second one is green. Third one is blue. Fourth one is yellow. Fifth one is orange. Here, these 5 LEDs are placed here. This one is a cathode, this one is anode. Tinkercad here, ground terminal is pickup here. To make ground here. All cathodes of these LEDs are connected to ground. Okay. Next, coming to resistances. This one is these pins are whenever these digital pins from choose digital pins from 13 to 9. These digital pins are acts as output pins. That means acts as the power sources. 5 volts. That 5 volts is not directly applied to anode of these LEDs. Through resistance only applied. Here resistance is connected here. Here another one is connected. Now next step is completed. Connections are completed. Next code. Here we use some text. Continue. Here for a single LED, the code has been written here. We will see. Start the simulation. What happened? Only one diode is blinking, but our aim is 5 diodes are blinking in increasing order. Now I have to write the code here. No need to write here. This one not required here. Pin mode. Here we use pin mode. We choose select 13th pins. Here we select 13, 12, 11, 10, 9. First of all, configure these pins. These pins are acts as output pins. Pin mode. Here 13th pin acts as output. Five statements are used to configure these pins. 1, 2, 3, 4. Next 5. Next here we use a 12th pin. 1. Next 11. Once these pins are configured, next go for execution block. Here, the first LED will be blink. The first LED is made to blink one time. Here we use digital right. First LED means here 13th pin is connected to first LED. Here we use some 100 milliseconds. Wait for 100 milliseconds. Here we use 13th pin is low. Delay is 100 milliseconds. Wait for 100 milliseconds. Completed. Here, next, the second LED is the second LED will blink 2 times. The second LED, the second is will blink times 2 times. Where phi is equal to 1, phi less than 3. That means 2 times the loop is created, rotated. Phi less than 3, I plus plus. Digital right. Here we use same statements. Digital here we use 12. Here 3 times. The third LED will blink 3 times. Copy, same copy here, and have to change something. The third LED. The third LED will blink 3 times. Will blink 3 times. Integer I is equal to 1. Instead of 3, here we use 4. Same here, we need to change blink 11. Next fourth LED. The fourth LED will blink 4 times. times. Here instead of here we use 4, 5. The 4 times the loop is repeated. Here we use 10 instead of 11, 10. Next one. The fifth LED will blink 5 times. Here we use 6. The ninth one. Here 9. Here close. Here the third LED will blink 3 times. Close one. The fourth LED will blink for I is equal to 1. These two curly brackets are playing an important role here. Otherwise, we will get some errors. Okay. Instead of that code here, we use change instead of 100 milliseconds, 1000 milliseconds. That means 1 millisecond. Here 1000, 1000, here 1000, 1000, 1000. Okay, start simulation. One, two, green light 2 times blinking, blue light 3 times. 1, 2, 3. Yellow light blinking 4 times. 2, 3, 4. And the last one. 1, 2, 3, 4, and 5. 5 times. 1, 2. We are not getting any errors. Successfully completed. Thank you.